No. No, no. What is the first one that we didn't do together? Number what? Eight. Okay, there you go. So I took a look at this aeronautical engineer. They want to, what's the lowest acceleration? So I want to find, well, actually, the lowest acceleration is 3 meters per second squared. Here's what I was given. Now, what I wasn't told is that the airplane started from rest, but every airplane starts. That's how VI equals zero. So that's called kind of hidden information. You have to use your common sense. That the one thing that they didn't give you, you should have had is VI equals zero. But it does, before it lifts off, it has lifts off. It has to have a velocity of 65 meters per second. You want the minimum acceleration is this. What is the distance? Well, the only equation that fits all that stuff is Vf squared equals Vi squared plus 2. Fits what you want and what you got. And that's the idea. Does it have what you want and what you got? Lamborghini with a velocity of 22.4 meters per second skids to a stop. Did you write Vf equals 0? What's the skidding distance? D. They give you a time. So initial velocity, final velocity, time, and distance. There's only one equation that has all those, and that's D is V average times T, or VI plus VF divided by 2. That's the only fit. Now, if you got something else, look at your equation that you got. It has something that you don't have. That's why it's the wrong pick. Maybe it has, I don't know. It maybe has acceleration in it. That was a bad pick because there's no mention of acceleration. How about Australian kangaroo capable of jumping to a vertical height? That's D. The takeoff speed, that's VI. Oh, now what's the hidden information here? When the kangaroo reaches his maximum height, VF equals 0. So if you didn't get that right, kangaroo reaches max height, VF equals 0. So there's the example of sometimes they don't tell you things outright, but think about what's going on here. And the only fit is Vf squared equals Vi squared plus 2AD. Good. All right. Now did I X this one out? Yep. Okay. Then we'll go to 12. Bullet leaves the rifle at, well, that's VI. I'm sorry. Bullet leaves a hyperbola with a velocity of, so it starts at 0 and it leaves at 521 meters per second. It accelerates in the gun for that amount of distance. So what did they mention? VI. Now, here's the other thing. I have to assume a bullet starts at 0. So they didn't tell me that, but I have to use my common sense. VI equals 0. VF is 521. It's that distance. What is the acceleration? You have to have an equation with acceleration in it. So if you pick the wrong equation, what did it have that you didn't have? Did it have the thing you wanted, too? You wanted acceleration. You better have acceleration. All that you have, all that you want. Baseball is hit straight up in the air. And determine the height. Well, that's another one. VF equals 0, right? When it reaches the peak, if you got it wrong, you didn't pick that equation right. Peak. VF equals 0. And that's the fit over there. Tall sky. Any questions on 13? Tall skyscraper, you drop a penny. VI equals 0. They didn't tell you that, but when you drop something, you let it go. To the rest, let it go. VI equals 0. It happened on the Earth. They didn't tell you that, but A equals 10 meters per second squared. It's the Earth. How much time? T. And it fell a distance 370 meters. Right. VI equals 0. Sorry for being so sloppy. That is, when you drop something, you hold it still and let it go. Okay. And rifleman's bullet, 367. That's VI. Lodges itself into a soft clay. What is its final velocity? Well, once it stops, it's VF equals 0. There's the acceleration. You want the acceleration?
So wait, the reason that you start with 0 for
I think it's inside the gun,
Okay.
Where inside the gun, it starts at 0, and when it hits the end, rifles by the speed of 360, when it lodges itself into soft clay. Oh, actually, so it lodges itself into soft clay, it stops. VF equals 0.
Okay.
In the clay, VF equals, what stops? VF equals 0. VI equals that amount, and then you go, there's the fit. And then a boulder is, oh, that's a good word, dropped. Held still, let go, circle, drop. 3.41 is a second. Determine the depth, that is a D, a delta. And so you see that? So you can kind of get the pattern here. Jaguar left a skid mark. That's a distance. It skidded to a stop. VF equals 0. A is negative 3.90 meters per second. What is its speed before VI? You get in the, it kind of, after a while it kind of sinks in. Is it sinking in, the method? Notice I underlined, you should do that too. Underline all the keywords and numbers. Did anybody get anything on the bottom you want me to talk about? Okay. Did you get right on the bottom?
No.
Which one do you want to go?
I just kept putting.
Well, now you know that you want to see, does your equation match everything? Like, why couldn't we use this? Let's go over this one. Ready? Let's go over here. Like 18, takeoff speed, that's initial speed. That's a distance because it's meters. Determine the acceleration and the time required to reach that speed. Actually, you need two equations for this. For the acceleration, you need this equation. And you know what? To get the time, you would use F equals VI plus AT. Do you see how you just can't use an equation? It's got to have everything that, look what we had VI. In 18, we had VI, D, VF, and A. Well, there's only one equation that has VI, VF, D, and A. It's right here. See? So does it match? Yeah. Sure. So what do I got? What do I want? And what fits? What do I got? What do I want? And what fits? So 19, there's a VI, there's a D. I don't think, do I have the answer for 20? Let's see. 20. If 1 meter, what speed must have to be thrown to reach a height? Oh yeah, that's D. Now peak, that's the peak. VF equals 0. This happened on Earth, and VI is the unknown. So what equation has VI and VF? A and D. Yeah.
How would you know when you have them?
Well, you know, in a projectile problem, when something's a projectile, it leaves someone's hand, it goes up in the air. Then I have acceleration because it's the Earth. It's negative 10 meters per second squared. Now, when don't I have acceleration? Well, let's find when I don't have acceleration. I got acceleration, got acceleration, I guess all of these seem to be, the fact of the matter is, these problems are all acceleration problems.
Wait, but it's not.
Well, yeah, you don't, in a car, it's like you'll see accelerations, it's not 10 meters per second squared. Only if it's a projectile. If it's falling or going up on Earth, yeah. Well, let's see, maybe I was wrong. Let's see, I have VF, I have VI, I have A, and I want T. Perfect. Well, from the prior question. Now, that's not a good strategy. We don't like to use things that we've calculated, but if we have to, we have to. Yeah. Well, that would be, because I think there's a second question and the time required, right? Did you see that there were two parts to that question? That would be for 18, yeah, because there was two parts to that question. All right, girls. So tonight's homework is twofold. One of them is this sheet over here. Now be really careful. Write yourself a little note to self. Don't do this whole sheet. Maybe you write it in like fake pencil. Do exactly what Google Classroom tells you to do. Don't do any more. I excluded a lot of this here. Now a lot of this is actually going to be something. This is all something you did before. Like look at the first page. You know what static friction is. You know what kinetic friction. You know the equation after the first page. Now let's go to the next page. A wooden block with a hook is placed on a horizontal aluminum cable. You would given the following supplies and asked to find the coefficient of kinetic friction. Well, write a procedure that you would do that. Well, guess what? You did do that, didn't you? With the hook and a scale. You just have to remember what you did. How did you hold the scale? How did you move your hand? There are 5 lines. You'll probably just use you won't use all 5. Okay, and so you don't do the whole thing. I don't think you do anything past 3, but I could be wrong. And that's it. So don't do the whole thing. Now, what else do you have to do tonight? Let's take a look. How do I get rid of this? Oh, okay, let's take a look what else you have to do. Today is, so homework for today. You have to do, paid pre-lab, friction lab. If you haven't already done your, girls, if you haven't already done your slope, could you do your slope for your plot that you did? Because that slope will give you mu sub k, the kinetic friction. Look at Google Classroom, yeah.
Page 5.
Oh, yeah, that is, yeah, so it says pages 1 and 2, 5, last page, just question 2, yeah.
Okay.
Dropping up, that's it, so it's not a lot of work. Not a lot at all. So let's get out what we would do in an object projected horizontally. The AP loves an object projected horizontally. I think that's where we were. Yay. So let's go over it again because it's brand new. What is an object projected? This is not an object projected horizontally, nor is this. But in basketball, they call it the chest pass. Chest pass. Chest pass, right? Chest pass. Boy, that was not horizontal.
Someone didn't play basketball. Not play basketball.
So you're neither throwing it up nor down. Let's see what's true. Oh, one more thing. Once it leaves the hand, how many velocities does it have? 2. Vx and Vy. Physicists solve problems by looking at the Vx velocity and the Vy velocity separately. So get used to that. It's kind of weird. You say it's one ball and you're talking about the Vx and the Vy. That's kind of weird, isn't it? But get used to that weird. Vx and Vy. Okay, next question. How many forces are on the ball once it leaves my hand? How many forces? Good. Because what we do is we say, this almost always the AP Physics one says ignore friction, or say that it's negligible. Just one. This just and gravity is a vertical force. What are the when I let go of the ball? What are the sum of the forces in the? How much of the sum of the force on the ball? Oh, good, 0. Which for a lot of people kind of weird. Really, there are no force in the x direction, and the sum of the force in the y direction. Well, that's ma. That is actually sum of the force in y direction. Of the two velocities, only one, the x or the y, or maybe just both. Only one will change. Which one changes, Cesare? Do you know? Is it the Vx that changes? Okay, we know now. It is the V. Oh, you weren't here. It's the Vy that changes. That's because gravity is a vertical force. Let me see if we can squeeze that in. Let's see. VIY equals 0. AY is 10 meters per second squared positive. AX is how much? Is AX the horizontal acceleration? 0. Next to AX is 0, right? What if they wanted me to prove it in physics? Sum of the forces in the x equal 0. Oh, I handed it out when you were out. You found it on the.
It's at the top there.
So yeah, that's if you ask me why does this x equals 0? Well, it says sum of the forces in the x direction equals 0, then the acceleration is 0. Okay, let's go. What do we like? So when the ball is projected, it goes forward and down. What do we like to call down when there's only down movement? I'm sorry, let me put it different. When an object is vertically going down, what do we like to call down? Beautiful. Let's call Vy is positive and delta dy, well, that's positive too. We get to decide what's positive, and that's what most people do. They call forward positive and down positive. Because all the vertical forces are down, why not call it positive? Now, Vx is, because the horizontal acceleration is 0, Vx is we're doing so well, by the way. Vx is, well, yeah, constant. Terrific.
Wow.
Now, next to it, what's the physics behind that? Because sum of the forces in the x, could you write Vx is constant? Because the sum of the force in the x direction equals 0. Okay? All right, so now let's get to the nitty gritty. The nitty gritty, let me make this nice and big. And it's going to be a little tough. We're going to get into a little tough area. This is the path of a projectile. Let's put some dots here representing the position of the ball. Oh, let me make this, get this to work. Okay. So we're going to say this is the projectile path for an object projected horizontally. And, it starts out right here at t equals 0. I'll put a little dot right, oops. So that it starts out at t equals 0. It's right here. And then it's right here. Everywhere it crisscrosses over the dotted line, that's the position of the ball. So everywhere the path intersects the dotted line, so the ball at 0, the ball at 1 second, the ball at 2 seconds, the ball at 3 seconds, and the ball at 4 seconds, it hits the ground. Now, we're told that Vix equals 30 meters per second. What does that even mean? V stands for, obviously, the velocity. I stands for, and X stands for horizontal, right? So someone threw the ball pretty fast, 30 meters per second. They're probably a machine that did this, because that's really, really fast. That must have been a machine. Okay. And then we look at the ball at all different positions. I asked you for the Vix and the Viy. Let's do something really easy. Since it's thrown horizontally, what's the VIY? All right. Because you threw it horizontally, you gave it no vertical motion. And then, so we're going to look at the ball and ask, what's its Vx, what's its Vy? 1 second later, its Vy is not 0, but it is because it happened on Earth. 1 second later is how much? Good. We get to say it's 10 meters per second because gravity does what? It always adds the same amount, 10 meters per second per second. You know, Haley, it's actually 9.8, but we get to see. All right, 1 second later, what's the Vy of the ball? 1 second later, 0, 10, 20, positive. I'm calling down positive. So this is really easy. You get the pattern here. Each second, the vertical velocity, and then when it hits the ground, it's positive 40 meters per second. Now let's deal with well, I don't know, this might be easier. What about the horizontal velocity of the ball every single second? Like after 1 second, it's right. Straight down the line, right? Straight down the line, because there is no horizontal force on this ball. So Newton would tell us, well, then there's no change in velocity if the net force is, oops, I guess this goes over here, right? Now, that's kind of weird. I mean, at every point, it has a Vx and a Vy. The next question at the bottom, I think, is, oh, you know what? What's the speed of the ball at 3 seconds? I have the Vx and the Vy, but they want the speed, the single speed. I want to take those two vectors and join them to a single speed. When they're 90 degrees, I know how to do that. Yes, yeah, let's find the resultant. All we do is that, so what we say is, okay, if you want to find the single speed, well, at 3 seconds, I know that it has a Vx of 30 meters per second, because my picture says, and I know that it has a Vy of 30 meters per second. Now I want to join that. I want to add those vectors. I find the resultant. And because they're 90, I have a nice little trick. How do you add vectors? Right. So you use the P by TH, and you say the speed is simply the vector combination. So 30 meters per second squared plus 30 meters per second squared, which is what, 1800, equals the speed squared. You know, because a squared plus b squared equals c squared. So that's 900 plus 900 is, yeah, I got that right, 1800. And the square root, will someone take the square root of it? 42.4, we'll call it 42. 40 speed is 42 meters per second. If you got hit by that ball, man, you'd feel a ball that just hit you at 42 meters per second. So you see how, as physicists, we love to do this. When we solve problems, we break things up into the y and x component, and that's how we solve it. We've got to say, how fast is it going horizontally? Vertically. That's a lot. Did you absorb all that?
How do you know?
Well, because x and y is always and y are always perpendicular to each other. So that's how you add up all perpendicular vectors. This is really interesting and kind of weird. So, what's this? A ball is dropped from the same height that 3 other balls are propelled horizontally. This is going to be a little hard to accept, but it's true, and I'll even do a demo a little bit. Ready? So when all the balls start here, when this ball is here, well, this ball's here, this ball's here, and this ball's here. When this ball's here, this ball's here, this ball's here. And at every moment in time, they have the same what? An object dropped and an object propelled horizontally have the same. Well, that's right, vertical velocity. I hadn't thought of that. They all have the same. They're all gonna right. All spheres have same. They have a lot of things the same. Same Vy, vertical velocity. What else do they have the same? Good. It's all 9.8. All the same AY. You know what else they have the same? Oh, good. Drop time, same T, right? And there's one more thing that they have the same. It's a D, but it's a D what? D, right. So there's the mathematics as to why they're going to, at every moment in time, why do they always have the same dy? Because they have the same vi. Oops, my bad. Well, yes, I'm going to say it's true that, but they also have the same viy. They're all equal to 0. So why do they all have the same dy? Well, do you remember this equation? D equals vit plus 1/2 gt squared, right? G. So they have the same VIY, they have the same T, they have the same G, and so of course they have the same DY. and they all hit the ground at the same time. Let's write this down. All spheres, and this is really odd, and they love to test this, hit ground at the same time. It's just so weird, isn't it? You ever see Mythbusters? One day they did a cool thing. They had a bullet held by a clamp and a gun right next to it. This is kind of a classic thing that physics teachers like to blow their students' mind. And they released the bullet and shot the gun. Of course, the gun was horizontal to show that what? The bullet that fell hit the ground. It almost feels like it can't. When I first saw it, I thought it was ridiculous. You're probably thinking the same thing. The bullet that was dropped hit the same time they proved as the bullet that was shot. Of course, it was shot one was way down, across the warehouse that they shot it. But people don't even think bullets fall. Bullets fall, yeah.
How did they have this
Oh,
drop?
no, they didn't have the same initial. They had the same VIY.
So
VIY.
when they both started to fall, that's when they had
Yeah,
the
so
same-
they both had a VIY of 0. And here's the thing, whenever I bring this up, the notion that a bullet drops is so weird because if I shot a regular gun here, it would basically, if I shot it from this height, it would basically almost hit the wall at this height and be a slight drop. I was saying this in a class 25 years ago, and a guy raised his hand and said, I'm in the Junior Olympics and I do rifle shooting far away. And there's no question, I'll tell you right now, bullets do drop. My target's up like a half a mile away. And if I don't account for the drop of the bullet, I don't get the beat. all know that we have to calibrate. We have something on the gun that will calibrate the drop of the bullet. I thought, isn't that a good?
Can you show us?
I'll be showing you really good videos on this in a little bit. So, but I actually have a demo, but I want to get through this. Oh, that I don't have. You can Google it. You can Google Mythbusters bullet shot horizontally. Okay, so they all hit the ground at the same time. When solving two problems in 2 dimensions, we must separate the x info from the y info. When solving problems in 2 dimensions, we must separate. Technically, you separate them and never allow them to come back. Get them apart and don't ever allow them to go back together. So, in an object propelled horizontally, the equations are ready. Now, you already told me that ax equals 0 because the sum of the forces in the x direction equals 0, and you told me the vx is constant, right? So you know what that means? There's only one equation in the x direction. This is it. Done. That's the only equation. Dx equals vx times t because there's no acceleration. Now on this side, let's all just change. All we have to do is change the equation. Put little y's on everything that you see there. Stick a little y plus viy divided by 2 times t. So all you do is stick little y's in there. Delta dy equals viyt plus 1/2 g t squared. What's that little g I put in there?
The acceleration.
Acceleration due to gravity on the Earth. Vfy equals viy plus, again, gt. So I'm modifying the main equation to allow me to do x and y. This is g, which is 10 meters per second squared, either positive or negative depending on where it's going. Oh, actually, when because it's going down, we make it positive. And VIY, the most important thing is VIY is how much. When you throw a basketball horizontally, VIY equals how much? 0. That's the most important thing. That is, put a nice big star next to that. Yeah, that's a big deal. VIY equals 0 as soon as I see that. So now you have the equations. One equation's on the x side and a whole bunch of equations. Oops. Let's do this one over here. VFY squared equals VIY squared plus 2g dy. So modifying the main equation to work in each. Alrighty, girls, read that next question and underline. What are the key words? What are the key numbers? What are the key words? What are the key numbers? So tell me what to underline. I don't know. Tell me what to underline. What do I underline, Carly? 40 meters high. I wonder what dimension that is. But what should she have underlined even before that? This is actually the main thing right there, thrown horizontally. I'm going to stop right there, thrown horizontally. Let's go to the y. Let's make this the x side and the y side. We're separating the x from the y. Oh, good. Thrown horizontally. I know what to write. VIY equals what, Juliana, what is it equal? Of course. Right away, I don't even read the rest of it. I just write that. And AY happened on Earth, positive or negative 10 meters per second. Positive. So I don't even read the rest of it, Carly. I just stop right there. Now, 40 meters high cliff. What's that mean? 40. What's that? What side does that go on? 40 meter high cliff. So I'm just, I'm just writing stuff down. How fast did he throw the lacrosse ball? Oh, what's that? How fast did he throw the lacrosse ball? Which side does that go on? How fast? Which of course is just the x. How fast did he throw the lacrosse ball if it hits 45 meters from the base of the cliff? Where does that go? 45 meters dx. You all see what she's saying? How about a little picture is always nice. So it's a cliff, right? This is what she's talking about. See? Now, okay. I can't bring everything back together. They're separate. And I look at this and say, oh, I remember him telling me that there's only one x equation. So this must be the one I have to use because there's only one equation. Wait a second. 45 meters equals, how could I find Vx? You know what I realized? I need t. Where might I get t from, girls? Where do I go to get t? Let's write need t. Need t. So let's go over here. That's one thing that can go on both sides. Time can go on both sides because really it's neither an x nor a y. All right, so t equals question mark. Now let's go to our equations and let's see what do we use. What's the fit there, Miss Lynch? You see the fit? Keep looking. What is the perfect fit? It's got VI, it's got A, it's got D and T. You found it, didn't you? I totally agree. So delta dy is 40 meters. VIY, isn't that just, well, that's just 0, isn't it? Plus 1/2 positive 10 per second. 40, 5t squared, t equals, someone do that for me? So they would have the square root of, I guess that's the square root of 8, isn't it? So it's like 2 point something. 2 point what? Because you divide both sides by 5, you get 8. 2.8 what?
2.8.
We'll call it 3 seconds. All right, so now we go back over here because this is going to get us the answer. And now I say 45 meters equals the x times 2.83 seconds. Now I just divide both sides by 2.83. Right there. The only x equation. Only one x equation. So you have no choice at all but this right over here. This one. Oh, I'm sorry. But let me make sure everybody's good on copying this before I exit out. Good. And what did you get as an answer? Yeah. 15.9? What? Meters per second, right? Okay, so sorry about that. Did you not get the last one? So all you have to do is it's just VFY squared equals VIY squared plus 2GDY. That's the one you needed? Okay, sorry about that. All right, now let me stop talking so much. You underline all the information, the keywords, the numbers, and then start to put stuff in the boxes. Make the left side x and the right side y. You would separate the x from the y in these projectile problems. What are the keywords? By the way, Erica, this was not explained. She threw it horizontally. Could you write a little note to self? I think this was badly phrased. Let's say that Erica threw it horizontally out the window. Erica throws a ball horizontally out of the window. Stick a little horizontally in this. So turn all this stuff into letters. We've got a minute left. When you see thrown horizontally, what do you put on the y side? Two things, right, girls? What do you put on the y side? Who knows? VIY equals 0 and AY is 10. I usually just stop what I'm doing. I put it right down. And then I read the rest because I say I'm going to forget. VIY equals 0. AY is positive 10 meters per second squared of the y side. Now, that 3.80 meters per second, what side does that go on? X side. That's an X one. The X is 3.80 meters per second.